A very good evening to all the participants for this 6 days online FDP on IoT and Cybersecurity in Power Systems, sponsored by Atal of the Department of AAA of KLN College of Engineering. So today is day 5 and session 9 is going to be handled by Dr. G.Y. Raja Vikram sir, who is an assistant professor in SRM Institute of Science and Technology, Katankulattur in Chennai. So he's going to handle the session and the topic Cyber Physical Power System. So before getting into the session, I'm very happy to introduce our session speaker to this forum. So Dr. Raja Vikram sir, he has received his MTech degree in Control and Instrumentation Engineering in 2011 and PhD degree in Electrical Engineering from Tyagaraja College of Engineering, Madurai, India in 2017. He is an assistant professor with the Department of Electronics and Instrumentation Engineering at the SRM Institute of Science and Technology campus at Chennai. He was selected for the Council of Scientific and Industrial Research CSIR Senior Research Fellowship Scheme of Ministry of HRD Human Resource Development in the year 2012. He was a gold medalist at the master's degree. He has authored 10 international journals and several co-authored international journals. His research interest includes cyber physical power systems, power system stability and control, the modeling and simulation of large-scale power systems, modeling and simulation of fax devices, wide area monitoring and control of power systems, intelligent control, and system identification. He is a member of IEEE, Power and Energy Society, and the IEEE Control System Society. Sir, we are very much happy to have you for this session in day 5, sir. Session is over to you, sir.
Yes, sir. Thank you, Thangasankaran, for your introduction. So, first of all, good evening to one and all. I like to thank Dr. Nyanambal Madam and Lovundare sir for giving me this opportunity to share my research insights with the audience to you. Sir, I share my screen, sir.
Please.
Yes, sir.
Sir, actually, sharing option is not enabled for me.
Just 1 minute, sir. I'll make you as a co-host so that you will get that provision, sir.
Okay.
But actually, some of them will be getting inside, so they'll get their admission. Logundre sir and myself will take care of it, sir. You just continue with the session.
Okay.
Yeah. Sir, have you got the provision, sir? Yeah. Yeah, it's visible, sir. It's visible, sir. Just turn on your mic, sir, please.
Sorry. So, can you able to see my screen?
Yes, sir. It's visible. Sir.
Okay. So, good evening to one and all presented here. So, today my topic is cyber physical power system. So, today we will see the cyber physical power system. What is meant by CPPS? So, how it is started in electrical engineering, the applications of CPS in electrical engineering. So, this is my outline of the presentation. So, first we will see what is the basic definition of power systems. So, introduction to power system. Then the second one, introduction to cyber physical system. So, how to define the cyber physical system? What is meant by CPS? Then we move on to the application of CPS in electrical power systems engineering. So we are calling it as a cyber physical power system. So first we will start the introduction of power system, then what is in the CPS, then how the CPS is very useful technology for electrical power system. So that is called the cyber physical power system. So after discussing this basics of CPPS, the fourth topic is very, very important. So what's meant by cyber attacks and what are the cyber security technology in cyber physical power system? So far, you know that what are the types of faults. So in addition to the electrical fault, we will see the types of attacks in power systems. And last one, I hope we all interested in this domain. So research areas in cyber physical power system. So I will list out some of the research areas so that you can, if you are interested, means please join our research team for continuing the research in cyber physical power system. So introduction to power system. So the main, the four elements power systems, we will categorize the power systems into four main divisions. So the first one is power generation. So as you know that we are getting the power from any source of any one source of the energy. So whether it may be a thermal power plant or a nuclear or hydro or any type of the renewable energy sources. So with this any or combination of this power generation sources, we are getting the energy from the power generation. So the important part of that power system is power generation. So after that power generation is over, we are transfer the power in the two methods. So one is wired power transfer, another one is wireless power transfer. So in the wired power transfer, you know that after the electricity is generated, we use the overhead line. That is a OH line using the tower for transmitting that electrical power. And another method is wireless power transfer. So nowadays, it is another booming method in wireless power transfer. And third method is, you know, that UG cable. So underground cable, of course, we are using for transmission of the electrical power. So the first the starting point of the electrical power system is power generation, and then power transmission, and then the third element is distribution, power distribution, and then the last end stage is power consumption, or it may be call it as a load. So these are the four domains of the four classifications of electrical power systems. So what we need, of course, we need the monitoring, control, and protection. So in order that the proper functioning of this four system, so if there's a four systems to be properly function, we need a continuous monitoring, control, and protection systems. So otherwise, this is not possible. So otherwise, your system may be unstable, or if any failure occur, means the system will be completely collapsed. So that's what the very important thing is. We need the monitoring control, that is a wide area monitoring, control, and protection of this four subsystem: generation, transmission, distribution, as well as the last end effect is called as a load. So this is the basic structure, or we can also call it as a traditional structure, conventional electrical power systems. So you can see this, the starting point is a generating station. So we can see this, the first one, the power generation, so power plant. So it may be a thermal, nuclear, or hydro, or nowadays we are having the distributed energy sources. So your voltage is the maximum generation voltage is 11 kV or 33 kV. And using the step-up transformer, we are stepping up to the voltage of 132, 220, or 400 kV. So this is your step-up voltage. That is the initial transmission system voltage. So after that, it is transmission using this overhead line, and then again it is a step down to the sub transmission system. So now the voltage is stepped down to 66 kV from 400 kV. Then after step down from the sub transmission system, so the voltage is the 66 kV rating, and then the 66 kV is again stepped down to 11 kV for some industrial applications. So from 11 kV to 33 kV, or 11 kV to some 33 kV for some medium customers. That is next to the high end of industrial applications. We need the voltage rating of 11 kV or 33 kV. And finally, we are getting the domestic application residential voltage of 230 volt. So this is the basic structure of electrical power system. So nowadays, the maximum voltage given in this diagram is 400 volt, 400 kV. But presently, we are transmitting the 765 kV voltage in the overhead line. So that is the highest transmission voltage in India. And within 1 or 2 years, we will attain the 1100 kV. So that is under construction in northern part of the India. So already China and Russia attained the level of more than 1000 kV transmission of voltage. That is transmission voltage is attained by the current infrastructure in the China and Russia. So very soon we also will attain the highest transmission voltage in India. So this is the basic structure of electrical power systems. So now the problem in this power system is we are not having the advanced monitoring and control and protection of the system. So in this conventional electrical power system, we are having the conventional system for monitoring, protection, and control. So in order to improve, in order to have the advanced technology, we are moving to the next one, the structure of the power system. So you see this, the conventional structure of the power system. The previous diagram is a centralized power system. So the what's by centralized means all the generation sources are centralized to the a common transmission substation. So you see this, all the generation sources are combined together. So hydro, nuclear, and a thermal power plant. So all the generation sources are combined. So and then even the renewable energy sources, wind, solar, and then tidal power plant. So both the conventional and non-conventional energy sources are combined into the a common transmission substation. So from the common substation, we are transmitting using the overhead transmission lines. So and then it forward to the distribution substation. So from distribution substation, we are based on the depends on the type of the customers. So whether a high voltage customer or medium or low voltage customer. So it is further divided into factories, residential users, and commercial users. So the main drawback in this centralized power system is if there is any fault in the transmission substation. So suppose if there is any fault in this transmission substation or any that fault or blackout occurs in this substation, what will happen? The power flow to this factories and residential users and the commercial users are completely interrupted. So we are not having the advanced monitoring and control. So this centralized power system is a completely failure system in the earlier days. So in order to avoid this kind of thing, we are moving to the modern power system that is called as a smart grid system. So in the smart grid system, we can see this. So one side the load of the customer, the factories, and then power generating sources, nuclear power plant, thermal, hydro, solar, and then wind power plant, and then the load, whether it may be act as a load or a vehicle to grid also possible in the electric vehicle, and then the domestic customers as well as the residential users. So all are connected to a common communication line. So you can see this. So even there is any fault in the generation side, so it won't affect the other generation sources. And also, if there is any fault in the one transmission system, it won't affect the other transmission system. So this is possible because of a decentralized as well as a distributed structure. In addition to this, we are having a advanced monitoring and control in this modern power system. So the meaning of the smart is we are having more advanced ICT technology. So in this, the structure of this modern power system, the information and communication technology plays a major role in maintaining the continuation of the power flow. So with this smart grid applications, we can maintain the power in a continuous manner. There is no interruption, as well as the customers also based on the demand they can avail the power, and also based on the demand they can sell the power. So this is possible only in this smart grid infrastructure. So the continuation of this modern power system, why it is called as a modern power system, sir? So you can see this, the first one is smart home appliances. So compared to the previous centralized power systems, nowadays you can see this, the home appliances are completely modernized. So for example, the safety and the security systems. So if you take any the home applications, definitely you are having the building management systems. So your complete the home is fully monitored automatically with the AI, and the power consumption pattern also you can analyze it. So how you can able to save the energy. So everything, it is completely modernized and automated home appliances. So even your refrigerator and microwave ovens, everything are interconnected through the internet technology. So with your electrical applications. So the second one is distributed generation. So even you can export the power to the grid. So that will be also possible. So you can get some incentives during the high peak demand period. So that's what we call as a demand management or a demand response. And then the second one, smart meters. So nowadays there is no need to take the reading to come to your home and take the reading. So easily it will communicate what is your energy consumption. So they will they read the meter readings from their Tamil Nadu electricity board itself. So on the smart meters also can able to send the communication pattern also, the energy pattern also we can retrieve from the smart meters. So and then the fourth one, electric vehicle. So there are two configurations possible with the help of electric vehicle. So vehicle to grid and grid to vehicle also possible with the modern electrical vehicles. And then the data collection. So using SCADA, especially after the invention of PMU. So compared to the SCADA system, the phasor measurement unit, PMUs are very much useful for advanced scanning of the power system. So the PMU is also called as a doctor of the power systems, electrical power systems. So the scanning rate is very, very high compared to the SCADA systems. So the next one is a decision-making controller. So compared to the conventional power systems, the controllers are inbuilt with that is embodied artificial intelligence. So it will automatically take the decision and control your power systems with the help of AI. So with these technologies are added with a conventional power system. That's why it is called as a modern power systems or smart grid systems. So, what are the challenges we are facing in the present power system scenario? Current power systems, what are the challenges we are facing? Is the first one is a strategic imperative. So, the meaning is we cannot stop the changes occurring in the power system, or we cannot we cannot deny. So, the strategic imperative means so day by day there is a transformation occurring in the whole electrical power grid. So, that was the first challenge. So based on this, we have to change our load flow analysis, power flow analysis, fault analysis, and then assessing the power system stability. So everything is more advanced one. So based on the changes in power systems. And second one, market prices and tariff. So this also more advanced and changes compared to the previous years. So you know that nowadays we are getting the electricity bill for every 2 months. So even the 2 to 3 months, the Tamil Nadu government proposed the new proposal. Hereafter, you are going to get the electricity tariff every month. So they are going to revise the tariff rate, prices, and a new method of submitting the proposal for the consumers. Then same time, they are giving some concessions to the power consumers. So like that, there are changes occurring in electricity markets also. And third one, power quality and stability problem. So nowadays there are more distributed generation sources are interconnected with the power systems. So because of this, the power systems having some large issue related to power quality and stability issue. So because synchronous generators are completely replaced by this power electronic converters. So we are facing some the inertia issue in this power systems. Then fourth one is interfacing with other energy. So we are not only dealing with only electrical energy, so other types of energy also should be adaptable by the current power systems. So that also main challenges we are facing in the present scenario. And then the fifth point is resilient power systems. So previously, the 20 years back, we are talking about as a reliable power system. But nowadays, we are focusing on resilient power systems. So what's the difference means if any fault occur on the power systems, it has to be come back to the actual condition or come back to the healthy situation within some fraction of seconds. So it automatically it have to be solve the issue and come back to the original state. So this will be the advanced technology is called as a resilient power systems. So even though any unexpected disturbances or any type of failure, so it should be immediately rectify that without any human intervention. It should be come back to the original state. So that is called as a resilient power systems. And another definition is how much time it can be withstand, even the fault occur, how much time it can withstand by the system. So that is called as a resilient power systems. So the next technical challenge is forecasting the output. So this is another important research domain in the power systems. So the forecasting the output from wind and solar generators. So nowadays you can see this. There are a lot of distributed energy sources are integrated with the power systems. So it is necessary to upgrade the current forecasting algorithm so that you should forecast what is for the next 1 hour or next 12 hours or next 24 hours using the advanced algorithms. So the 10 or 20 years back, we are using some forecasting algorithms are is not suitable for the current scenario. And then the next one is a network flow. So definitely we have to be consider this the power flow, the network flow in this power system. So we have to be make the limit of the power flow in the power system. So within this technical limit only we can able to transfer the power. So even though the large distributed generators are interconnected, so we cannot increase the power flow in the system, sir. So the transmission line rating should be considered, as well as the equipment rating also should be considered in the network flow system, sir. So the next one is maintaining the frequency. So nowadays we are having a synchronized power grid. So from Kanyakumari to Kashmir, we are having the synchronized power grid. So maintaining this 50 hertz power supply is not an easy task. So previously we are having the four parts of the country. So northern, eastern, western, and the southern part. So 2012, because of not maintaining the frequency, we faced the blackout in India in 2012. So nowadays we are having a synchronized power grid. One India, one grid. I hope you heard about this. So that is the another challenges we are facing in this power grid. And last one is voltage rise and stability issue in this wide area power systems. So these are the technical challenges still we are facing in this electrical power systems. So in order to face this or in order to handle these challenges, definitely we need to go for some advanced technology. Otherwise, we cannot take these challenges easily. So that advanced technology is called as a cyber physical system. So CPS is nothing but it is a technology. So with this CPS, we are going to handle these challenges and face these challenges in the electrical power system. So the another challenge is you can see this allowable penetration of a variable generation and coordination with the grid. So just imagine there are a n number of generation sources are interconnected with the power grid. So the main issue is the coordination problem. So if you are not coordinated, the grid will be completely unstabilized and it will lose the synchronization. So this is another issue. That's what we are focusing on, a coordinated design and control of power systems. So the next one is a voltage coordination is another issue, and then the last one is a equipment limit. So these are the challenges we are facing in this electrical power system scenario. So we will see with the help of CPS technology, cyber physical system, how it will helpful for the power systems engineers to face these challenges. So introduction to cyber physical system. So what is meant by CPS means cyber physical system, how it came. So there are three departments behind this cyber physical system. So the first one is computer science, that is computing. So that is the first one. And second one is communication. So okay, you know that electronics and communication engineering. And third one, control systems. So of course, EEE or E&I. So these three departments, you can see this. These three technologies are behind the background for the cyber physical systems. So this updation of this three technology is not only helpful for electrical power system, all your other application domain, agriculture, transportation, banking, finance, water, oil and gas. So all these application sectors are upgraded or moving towards the advanced technology because of this triple C, computing, communication, and control. So these advancements providing a bridge between the physical components and cyberspace. So this leads to a technology is called as cyber physical system. So these three departments, these three technologies are very, very important for the back support of cyber physical systems. So because of this, we are connecting the cyberspace with the physical power grid. So this term is called as a cyber and physical, which is strongly interacted and interconnected system. So what is meant by computing? Now computing can be defined as sensing, analyzing, predicting, and understanding. So these are the tasks performed by the computing domain. And communication, the communication task is to interact with the system, to intervene, to interface management, and other type of communications with the systems. So the communication will take care of this kind of task. And last one is control. So in this control, it has to be interoperate with the other systems, and some evidence-based certifications also be there, how to control and work parallelly with the other systems, and make this system whole as a intelligent and autonomous systems. So you can see this computing, communication, and the control. These three are the having a separate functions and work together to control the physical system. That is our electrical power systems. So the complexity, what is the main difficulty or complexity in the CPSs? How to integrate this cyber components with the physical systems. So we know that electrical power system is a generation, that means a generator, transmission line, and a transformer and overhead line. So these are all the physical components. How we are going to integrate this the cyberspace components, that is this computation, communication, and control systems. So this arises the complexity in cyber physical systems, and the knowledge based on the CPS domain is mainly required. So for all the power systems engineers as well as the control system engineers. So then only we can adapt this CPS technology in the electrical power systems. So the basic knowledge of CPS, especially in the cyberspace, should be we learn about. Then only we can implement in the electrical power systems. So this is the building block of the cyber physical system. You can see this, the three technology. So one is the yellow color computation, and then the second one communication, and then the third one is control systems. So these three together formed as a triangular function, which is main support for the cyber physical system technology. So we are going to implement this technology for electrical power systems to handle the or to face the difficulty or challenges which I listed in the previous slide. So cyber physical system means it is a combination of, that is combining the physical system. So just imagine it is a generator, transformer, transmission line, electrical power system with the cyber components. That means communication, computing, and control. So it is not easy to combine or join the systems. The two systems should be strongly integrated and interconnected. So that is the main complexity in the cyber physical systems. So now we will define what is meant by physical systems. So generally the physical system means electrical power system is a physical system. Transportation, so normal the electrical vehicle transportation is a physical system. Water and oil, gas, so these are all the physical systems. So the man-made system, even biological systems also physical systems, examples of physical systems. So we are going to join the cyber system with this physical system, that is called as a cyber physical systems. So after joining these two systems, it will be strongly interconnected with the environment. So here the environment means your electrical power systems. So the environment means this electrical power system will interact with the cyberspace, that may be in the continuous time. That means a normal time, or it may be a ordinary time. So this concept of the merging or the joining of this cyber and the physical system is called as a cyber physical system. So the operating time may be continuous time or ordinary time for physical system, and the cyber system will be operating discrete time. So the cyber systems consists of processing, communication, and controlling information through computational elements. So generally, you know that the computation means we are having some advanced processor, and the communication advanced 5G or 6G communication, and the control system means we are having some distributed control system in that. So these three together forms the cyberspace in CPS technology. So who introduced this cyber physical system? The cyber physical system was first introduced in 2006 by a National Science Foundation program. So it was introduced by Dr. Helen Gill, madam. So she was a lady in a National Science Foundation in US. So before CPS, it is called as a cybernetics. So before the CPS, before the name of CPS evolves, it is called as a cybernetics. So cybernetics means it is a combination of control and communication in machines and humans. So with the help of control systems and communications, they connected the machine and the humans. So nowadays we are talking about the machine and then human collaboration, or HMI, machine and human interaction. So the past, that 2006, the 2 decades before, they merged the control and communication with the for joining the humans and machines. So after that, they introduced the concept of a cyber physical system in US. So the proper definition of a cyber physical system is interconnecting the communication devices that will be interacting with the physical world. So the physical world is completely a different operating time, and computing devices are operating in the different operating time, and both the systems are strongly interacting. So physical system will talk to cyber, and the cyber system will be talk to physical system. So this interaction is very, very strong in the cyber physical systems. So the main objective of cyber physical system is the cyber system will regulate the behavior of the physical world. That is, here the physical world represents the electrical power system. So the electrical power system is completely monitored and controlled by the cyber system. So the next thing is the three components. What are the three heart of the cyber system? So one is sensor, second one is a controller, and the third one is actuator. So these three are the very, very important part in the CPS: sensing, controlling, and then actuating. So that's what it is specified as a sensor, and controller is nothing but your computer, and then the last one, controller, that is a actuating systems controller. So these three are the very, very important. Sensors, controller, and actuators are the basic foundation for the embedded control system in CPS. So the first, the sensor will be sense the physical behavior of your physical power system, and it will transmit the signal to the computer. So the computer will, using the AI-based algorithm, it will generate the control signal, and this control signal is actuated by the actuator in electrical power systems. So this sensor, controller, actuator will be inbuilt. Embedded platform will be implemented as a embedded platform in a CPS technology. So you see this, the main difference between here, the difference is we are using the embedded control system. It is not like a conventional control system. So what is the embedded control system means? So this embedded control system is deeply intertwining between the physical and the cyber. So you cannot like a conventional control system for like a feedback control system. So it has a deep intertwining between the physical and the cyber. So we have to develop this embedded control systems. We need to have a full knowledge of the model of the electrical power systems. So then only we can develop this embedded control system. So the basic foundation for this embedded control system is developing the full a complete power system model. So that is called as a faithful model. So using this faithful model, using the system identification or data driven method also possible to develop the faithful model of the electrical power systems. So after getting the model, you can design the feedback controller using some control theoretic methods. So this is the basic point of control of electrical power systems. So after that working on that controller, we can implement that controller as the embedded control systems in CPS technology. So implementing the feedback control now. So for implementing this feedback control systems, we are using the embedded computing platform. So of course, if you are working on embedded control systems, you have to use the embedded computing. Again, embedded computing is completely different from the conventional computing platform. So this embedded computing platform requires the large computational resources. So using the current computing resources is not enough. We need some supercomputers to calculate the control signal for the distributed power systems. So therefore, I have specified as here the resources is the main problem in the electrical power system. Second one is very, very important, the memory and the timing requirement. Because of if we miss the timing, the correct timing of sending the signal, the power systems will be leads to unstable and blackout. So the timing requirement as well as the computing resources are very, very important in the electrical power systems, because power system is a safety critical system. So if there is any fraction of delay in the transmission of the control signal, it leads to the complete blackout of the power system. So that's what it is, a stringent timing requirements in electrical power systems. So generally, after designing this feedback control systems, we will use the formal verification technique. So this formal verification technique normally used in the computer science engineering. So they will check that whether the designed feedback control system is working properly or not. So they will test this algorithm before implementing into the practical power system. So because power system is a safety critical, so they without testing this algorithm, they directly they want to go for the field applications. So that's what the formal verification technique is used by this CSE people. So before implementing this algorithm. So the CPS concept map. So what is meant by cyber physical systems? So you can see this first, the first cyber physical system which requires. So cyber physical system is nothing but a feedback system. So which is possibly with a human in the loop. So we are also in the loop of cyber physical system. And the another definition is it is a feedback system. It requires both a networked and a distributed system, and possibly with a wireless sensor and actuation. So here wireless sensing also is possible, and it is a networked and advanced distributed system. So here the distributed is the advanced system, because we have seen the centralized system as a old one. And you see this, it is more adaptive and predictive systems. So which is more adaptable to the conventional the electrical power systems, and also more predictive what will happen in the future, that also possible. And then more intelligent and real-time systems. So these are the basic definition of from system point of view. Cyber physical system is a system point of view. They have given what is the CPS. And second one, you see this cyber physical system requires the cyber security. So here the attack problem, cyber attack problem is a major issue in the cyber physical system. So we need not a physical resilience, we need the cyber resilience, and then privacy also, of course, we need in the cyber physical systems. And then the attacks also possible, intrusion detection also we need in this electrical cyber physical systems. So the cyber security is the heart, that is a hard research domain in electrical power systems. And then it requires the design tool. So you see this, these are the design methodology and design tools for cyber physical systems. So this area is also a emerging area to design the CPS tools for testing and validation. So the first one is modeling and analysis, and then the second one is the complexity management of the cyber physical system. So in the modeling, you have to model as a heterogeneous system. So because of it is a mixing of digital as well as the analog system. So that's what we need, the hybrid and the heterogeneous models. Again, this is a models of computation. So using CSE concepts, I hope you know that the state machine, you studied in the digital logic circuits, state machine model and state machines, hybrid state machine. So using that, we have to model the cyber systems. So second one is discrete and continuous. So power system will operate in continuous manner, and the cyber system will be operate in the discrete manner. So we need to model both the systems in a interconnected systems. So, and then the three, networking, interoperability, and the time synchronization also very important characteristics. Here the time synchronization means we need to synchronize the continuous time as well as the discrete time. If there is any mismatch in that, the monitoring control will be, it will lose that operational efficiency in the power systems. So the last one is validation and verification of systems. So in your CSE concept, we have this certification of the developed algorithm and simulating the algorithm, whether it is satisfying the need. And last one is stochastic model. Some uncertainties are added with the power systems, and we have to develop some stochastic model. So up to this, the part of the CPS, what is my CPS is over. And what are the application domain? You can see this, it is applied for communication, consumer applications, energy, power and energy, and civil infrastructure, medical healthcare, manufacturing, military and defense, and robotics applications and transportation. So for all the applications, we need the cyber physical system technology. So the next one is coming to the our field domain, that is a cyber physical power system. Now we are going to apply the cyber physical system in electrical power systems. So you see this, the basic structure of cyber physical system. So here the physical system, any physical system, not only electrical power system, it may be a transportation, agriculture, water, oil and gas. So any physical system which is continuously monitored by the sensor. So here I am putting one sensor, so used to sense or monitor the any physical system. That's what it is specified as. It may be a plant, process or system. So using the sensor, I can monitor this physical system. Now using this ADC, analog to digital conversion, from the sensor, I am getting the analog data. Now this analog data is converted into digital data. This digital data is forwarded to the cyber systems. So now cyber system, you can see this, it is involving the software, or it may be algorithm, or it may be any computational devices or coding. So now the cyber system accept only the digital data. So we need to convert the analog data into digital data. So I am using this analog to digital converter. Now, after converting this analog to digital data, the cyber will send the control signal. So here the control signal will be generated by the computer from the cyber system. Now this is a digital data. Now the digital data is forwarded to DAC. That is again digital to analog converter. We have to convert it back and then forward it to the physical system. So this is the simple feedback loop system for the cyber physical system. So now we are going to apply this cyber physical system in electrical power system. So I hope you can see this structure of a cyber physical power system. So you can see this, the top one is a red color, that is one dotted line with a subsystem that is presented in the red color. And you can see this, the bottom one, it is shown in the blue color. So the red color, it indicates the flow of energy. So it is completely a physical system. That means hardware, that is physical power systems. And then the bottom one, fully the dotted line represents the blue color represents the flow of data. So the data which will be represented as a blue color representation. So you know this, that we have seen in the three parts of the power system: generation, transmission, and distribution. And last one is utilization of your electrical energy. Now these three subsystems are monitored by the power system control. You can see this power system control. So the generation side is monitored and controlled by AVR, automatic voltage regulator, exciter, and automatic generation control, and the power system stabilizer. So for transmission side, we are having FACS, flexible AC transmission system, high voltage DC transmission system, and the wind farm, and last one, load shedding, advanced metering infrastructure, and energy storage. So these are acting as a power system control. And all these control signals and then monitor signals are transmitted through the IED, intelligent electronic device. Now from the IED, I am transferring the signal to the cyber system. So through this communication, the signal will be come to the communication, and it will move on to the computation, and then it will pass on to the control. Again, it will be fed back to the physical power system. So the cyber system will continuously monitor your electrical power systems. So that's what it is shown as information flow. That is, information signal is flowing from physical to cyber. Again, the control signal is flowing from the cyber to physical. So by this the cyber physical technology, it is continuously monitoring the electrical power systems, and if there is any problem in the electrical power systems, immediately it will take the action and it bring back to the system to the normal state. So the main objective of the cyber physical system is a continuous detection. The monitoring and the detection is the 24/7 is done by this cyber systems. So in this cyber system, what is the main problem is the cyber attack. So you can see this in addition to the physical attack. So I have seen this as a physical attack. So you know that the physical attack means the line to line fault, a line to ground fault, a single phase fault, a three phase fault, or sometimes a lightning attack. So these are all the physical nature. Physical attack will be happen in the power system. So in addition to this, you see this, there are 2 points. The cyber attack also will be happen in this system. So one cyber attack will be happen in the transmission of the signal, and another cyber attack will happen on your cyber system. So we need to detect the system. So that's what we need, the continuous detection of the system. So after detecting the system, we need to protect the system using the cyber security algorithm. So this is the structure of a cyber physical power system, that is CPPS. So it will not only, it will protect our system from physical fault. So far you have studied the load flow analysis, the Newton-Raphson method, Gauss-Seidel method. So in addition to the load flow analysis, we need to perform the cyber attack analysis as well as the cyber security analysis also. We should perform in addition with the physical, that is a power flow analysis. So that is the main objective of we need to consider in this cyber physical power systems. So far, any doubt in this? Shall I move to the next one? Is any doubt? Shall I move to the next one?
Yes, sir.
Okay. So the next one, defining CPS and cyber physical power systems. So cyber physical system means you can see it is applied for any systems. So any network systems, it integrates. That is, any smart network systems, it integrates with computing, control, and sensing and networking. So that is the basic definition of the cyber physical system. And what is by cyber physical power system means we are combining the same computation, communication, and control with physical power systems. So this is the basic definition of cyber physical power systems. So here the two important terms are very, very important. So one is interaction and another one is interdependency. So what's in by interaction means the effect of the cyber system has some effect on physical power system, and this physical power system effect on some cyber power system. So this is called as a interaction, and interdependency means both the systems are depend on each other. So that is called as interdependency. Cyber depends on physical, and physical depends on cyber. So that is called as interdependency in the cyber physical power system. So next one is events. So events means nothing but the fault in the cyber physical power system. So in the conventional power system, fault means only occur in the physical power system. But in cyber physical power system, events means it may be occur in physical system, or it may be occur in cyber structure, or it is a dependent events. So it may be occur in physical power grid, power components, transformer, transmission line fault. So that is called as physical grid event. Or the fault will be occur in the cyber side, that is computer side, or algorithm corruption, or maybe a fault in the your network cable. So that is called as event in the cyber infrastructure. So the third one is a dependent. So if fault occur on cyber, it will affect the physical. If fault occur on the physical, it affect your cyber. So that is called as a dependent event in the cyber physical power system. So the next one is a difference between physical and cyber system. So what's the main difference means you can use this tabulation for any type of system, not only the power system. So you can see this the first one component. So here the electrical means a generator, transformer, transmission line, circuit breaker, relay. So these are the physical power components. And then from the cyber side, you can see this communication network, whether it may be a wired or wireless, and computing devices, processor, and third one is control systems. So next one is the nature of system, very, very important. This is fully continuous system, and this is fully a digital or discrete system. So again, the next one is the system state, very important. Here we are having the energy flow, and here the information or data flow in the cyber system. So this is the main difference between energy and power. That is data systems. And then you can see this, the another one, physical contingency. So the contingency means you know that the line fault, the ground fault, that is called as a physical contingency. So here it is called as a cyber contingency, means cyber attack, latency, or any type of control effects, malicious control effects. So that is called as a cyber contingency. And then the stability, we have already studied about a power system stability, but here we are calling it a network control system stability. And then the last one, the event synchronization. It is asynchronous. So what's the asynchronous means? One side fault, it cannot spread to the other area. We can easily stop this. That is called as asynchronous. But in